Welcome everyone. Today we are going to discuss a very beautiful problem from center of mass. The problem itself is very simple. We have a frictionless surface and a wooden plank placed on this frictionless surface. The length of the plank is capital L, the mass of the plank is capital M. We also have one person standing on one of the edges of this plank, and as the problem states, this person is moving from one of the edges to other edge. And while doing so, as the person moves back forwards, the plank would shift backwards. Why the plank is shifting backwards as the person is moving forward, that we'll discuss further in this problem. For now, let's talk about the concepts which we are going to use to solve this problem. The concepts are first, center of mass, and second, the relative displacement. Let's solve the problem. So initially, if you talk about the initial condition, which is this one, for initial condition, we have the position of the man. Let's suppose this is the position of the man given as Rm naught. We have the position of the center of mass of the plank, that would be Rp naught. Now let me repeat myself again. This is the position of center of mass of the plank. So if we want to calculate the position of center of mass of the system of the person and the plank, so we directly use the center of mass formula. We know that Rcm naught would be equals to small m, mass of the person, into position of the person plus mass of the plank into position of center of mass of the plank divided by the total mass of the system, which is n plus small m plus capital N. This is the initial position of center of mass. Let's suppose this is our equation 1. Now, for the final condition, let's suppose the position of the person is given as Rm and the position of center of mass of the plank is given as Rp. Now, pay attention that we are only using general terms. We have still not mentioned what are the conditions for this problem. We are doing this so that we can use the same concept for multiple problems. So again, for this final position, if you want to find out the position of center of mass, that would be given as is equals to mass of the man into position of the man plus mass of the plank into position of center of mass of the plank divided by total mass of the system. This is our equation 2. So we have found the center of mass of the system for the initial condition and the final condition. Now we know one situation that the ground is frictionless and the motion is happening in the horizontal direction. So we know there are no external forces acting in the horizontal direction. What is the meaning of that? That if external forces along x-axis are 0, that means acceleration of center of mass along x-axis would be 0. That is, velocity of center of mass would remain constant, and which would be equals to 0, because initially both plank as well as the person are stationary. The velocity of center of mass will also be 0. What is the consequence of this? That means the position of center of mass doesn't change. Since the velocity is 0, the position is not going to change. That means Rcm naught, initial position of center of mass, would be equal to final position of center of mass. So over here, we can just replace the values. We're going to get m into Rm naught plus capital M into Rp naught upon small m plus capital M is equals to. So I'm getting a little bit more time to write these things. I hope all of you are also following along, upon total mass. So you can see that total mass of the system would get cancelled from both the sides. Now, we have the position of man on one side, the initial position of man and the plank on one side, and the final positions on the other side. What we can do, we can separate the small m terms on one side and we can separate the capital M terms on the other side. So we have something like this. So this has come over here and this has went over here. Minus Rm. This is equals to capital M common. Rp minus Rp naught. Now if you pay attention, this is negative of displacement of the person with respect to the ground, and this is negative of, this is the displacement of the plank with respect to the ground. So we can write this as minus m into delta Rm is equals to capital M into delta Rp. Little bit, well, let's make this a little bit pretty. So we get something like this. So the significance of negative sign over here is what we have initially discussed, that if the displacement of the man is happening in the positive x direction, then the displacement of the plank would occur in the negative x direction, and hence the plank is moving in the backward direction. Now from here, even though we are getting a good formula, even though we are getting a good relationship between displacements of man and the plank, we are still not in the position to solve the problem. What is missing? We neither know delta Rm, we neither know delta Rp. So now we'll take the help of relative displacement or relative position vectors. Why do we use that? Because even though we don't know the displacement with respect to ground, we know that the person is moving from one edge to the other. So we know the displacement of the man with respect to plank. This is known to us. And we know from the relative velocity concepts that this will be equal to displacement of man minus displacement of plank with respect to the ground. So if you want to replace delta Rp, which is an unknown quantity, we can replace with something which we know. So delta Rp would be written as delta Rm minus delta Rp. This would go over here and this would come back over here. So this is what we know. We can replace this value in equation 3. So we'll get m into delta Rm is equals to minus m into, I hope everyone is able to see the board, minus m into delta Rm minus delta Rmp. We can multiply the mass inside. Right? We can take the displacement of the man on the other side because that is what we need to calculate over here. And from here you'll get this. Oh sorry, capital M would be here. We'll also have capital M over here and P. Just let me just correct this a little bit. Small mistake. M into delta R and P. So from here we can simply get displacement of man as mass of the plank upon total mass of the system into delta R and P, displacement of man with respect to plank. If you look at the diagram, now we can know all of these. We already know all of these formulas or all of these values. We know delta Rm. Delta Rm would be equals to plus x because the person is displacing x from its initial position. We also know delta Rmp, which is equals to plus L. With respect to the plank, the person is moving from one edge to the other. The displacement is capital L. So if you replace these values over here, we will get x as m by n plus m into L. So this would be the displacement of the person with respect to the plank or with respect to the ground. So I hope this was useful for you. I'll just give you a minute for the see the entire solution at one go. Okay. So I hope this was useful for you and I hope that you enjoyed watching this. Thank you everyone.